On this episode, we discuss analysis of an ancient skull found in China, suggesting the tantalising possibility that ancient humans evolved in Asia, went back to Africa, and then emerged out of Africa about 60,000 years ago, rather than doing all our evolution in Africa.
It could rewrite the entire Out of Africa narrative.
Yeah, huge if true.
Yes.
Welcome to The World, the Universe and Us from New Scientist. I'm Dr. Rowan Hooper.
And I'm Dr. Penny Sarchet. The claim is that this skull pushes back the origin of our species by 400,000 years. That's a really long time in terms of human evolutionary history. Science writer Mike Marshall joined us on this episode. Mike, hello.
Hello.
This skull is about 1 million years old, isn't it? And it used to be classified as Homo erectus. That's one of the earliest members of our family. But now it's been reclassified. Can you take us through it?
Yeah, sure. So this story actually goes right back to the tail end of the 1980s. So in 1989 and 1990, two partial skulls were uncovered, and they were in a terrace like above the Han River in central China. And both of these skulls had been crushed and sort of squashed while they were underground. So they were kind of deformed and damaged. The second one, which is called Yunxian-2, was the less badly affected of the two. Using more recent techniques, in 2010, a team was able to more or less reconstruct it. And now what's happened is that a team has gone in using even more advanced methods, 15 years later, and again reconstructed the Yunxian-2 cranium using a mix of techniques, including one that sort of uses CT scans, and they can digitally separate individual fragments of bone and sort of separate them from the surrounding rock and sediment that it was buried in. I'm
really pleased to hear this because I remember reporting on it a while ago about this method of CT scanning and then 3D printing stuff without even having to dig it up. And it's a great mix of modern technology improving on an old technique. But Mike, go on. They've restored it. And now what are we getting?
So the key thing is what species does this cranium belong to? Because it's about 1 million years old, 0.94 to 1.1 million, it's about 1 million years old. Generally, when you're thinking of hominins of that age from China, you're often thinking about Homo erectus. That's one of the earliest members of our genus Homo. Evolved in Africa sometime around about 2 million years ago and then spread out all through southern Asia, all the way to Indonesia, famously to Java, and survived there until a little over 100,000 years ago. You'd think that maybe this was a Homo erectus, and in fact that reconstruction in 2010 suggested exactly that. But the new analysis says, no, it doesn't. It just doesn't fit the Homo erectus profile. The nose is wrong. It's the brain size is just too big. There's a bunch of things that don't really fit. So what these researchers did is to compile 56 other hominin fossils and sort of compare it on as many different measurements and traits as they could to see how it fit into this sort of existing group of fossils. And putting them all together, they reconstructed a family tree, sort of showing how all of these different things are related to each other, just based on how similar are they. If two fossils look more or less alike, they're probably quite closely related. If they're really different, they're probably distantly related. Well, what fell out of that is 3 major groups, and that includes most of the fossils from the last 1 million years or so. One of those groups, Homo sapiens, modern humans, us. The second one is the Neanderthals, who sort of famously lived in Europe and Asia for hundreds of thousands of years until disappearing just maybe 40,000 years ago. And the third one is this very sort of mysterious group called the Denisovans from Eastern Asia, who we've only known about for 15 years. And what we see from this new study is that the Yunxian-2 skull seems to be a very early ancestor of a Denisovan or a Denisovan-like hominin. It doesn't fit the other two groups. It's in the Denisovan group.
So how does that change our understanding of things then? If all of those skulls from the course of 1 million years roughly split into these 3 groups, does that massively push back the divergence then of humans from Neanderthals and Denisovans?
Yeah, it's the age of Yunxian-2 that really sort of puts the cat among the pigeons in terms of reshaping the story. So the conventional story that's come out of the analysis of ancient DNA from the Neanderthals and whatnot is that there was this ancestral group, Ancestor X, that gave rise to Homo sapiens, Neanderthals and Denisovans, and that group sort of broke apart something like 600,000 years ago, more or less, and gave rise to these groups, with our group being the first one to break away then there's like this intermediate period where there's Neandersovans, like the ancestors of the other two groups, and then that group splits as well. And that all happens sort of around about 600,000 years ago. But in this version, based on this analysis, instead it all happens much earlier, over 1 million years ago. So the initial split is around about 1.3 million years ago. And also the order of the splits looks a bit different. So instead it looks like the Neanderthals break away first, and so you have this remaining group that's the ancestors of us and the Denisovans, and then that splits a bit later. Not much later, I have to say. It's a fraction of a million. It's a fraction, So I'm slightly sort of cautious about that, but at least that is what fell out of the data, is that the Neanderthals broke away first. But I think the really key thing is how early this is. It's hundreds of thousands of years earlier.
So, I mean, this is coming from an analysis of skulls, which is, how we've always tried to understand human evolution. And like you say, with the Denisovans, much more recently, there's been this shift towards DNA evidence and using those tools. I'm kind of surprised, actually. Normally, like DNA evidence, it suggests things are way older than there's any fossil evidence of. But this time it's the other way around. The fossils are suggesting something happened much earlier than the DNA currently suggests.
Yeah, it does. There's sort of two questions that immediately arise from that. First of all, is the fossil evidence sort of really telling us the right thing, or because they do seem on the face of things to be contradicting each other. There are some hints from recent genetic studies of like earlier divergences and like earlier splits happening, particularly in like the Homo sapiens population. There's evidence of like a split into two populations like 1.5 million years ago. And then later on, those populations sort of come back together and interbreed, and we don't really know how to sort of fit all of that together. But certainly, if you sort of take this at face value, then what it seems to imply is that there's a very long period when we're sort of missing a load of fossils. If the Homo sapiens group sort of splits from these other two groups 1.3 million years ago, that leaves basically 1 million years of missing fossils until we get to the oldest known Homo sapiens fossils 300,000 years ago in North Africa. And we're not quite sure what to look for, or what they would, or where they would be.
So, Mike, one of the researchers on this paper is Chris Stringer at the Natural History Museum in London here. And when you spoke to him for this story, and when you were talking with him, you asked him what it meant if these groups were already splitting from one another that long ago, more than 1 million years ago in China. What does that mean for this narrative we've all grown up with that we came from Africa? And here's Chris on that.
10 years ago, I would have said that probably Africa is the ancestry of most of these groups, and it's sort of pumping out these different forms. So the Neanderthals, Heidelbergensis, they may all ultimately trace their origins back to Africa. Certainly Sapiens does in the more recent past. There's no doubt there was an out-of-Africa event, maybe 60,000 years ago, which gave rise to all the variation pretty well of humans today outside of Africa, with a little bit of addition of interbreeding, of course, with these other groups. But the main variation, we're mostly out of Africa in terms of Homo sapiens. But if we go back 1 million years, where did the ancestor live then of us and Denisovans, Longi, and us and Neanderthals? And what our analysis suggests is that there is certainly a big question mark over whether it was Africa.
Well, that's kind of stunning, isn't it? That it can rearrange our whole narrative. Or is that, from your expert point of view, is that not entirely surprising, Mike?
Sort of, yes and no. So, as like Chris said, it is still true that like our most recent ancestry is from Africa. 60,000 years ago, there's this migration out of Africa, and that gives rise to all the populations all around the world, whether it's indigenous Americans, Europeans, indigenous peoples of Southeast Asia. They're all coming from. They all have that sort of same out of Africa ancestry. At the same time, I've been sort of thinking for quite a long time about like who is this sort of ancestor X, this group that gives rise to Homo sapiens, Neanderthals, and Denisovans, and it hasn't really made much sense to me to assume that they're necessarily in Africa, because you have the Neanderthals in sort of Europe and Western Asia, you have the Denisovans in Eastern Asia, and then you have Homo sapiens coming out of Africa. It almost, to me, makes more sense to sort of say, well, maybe the origin point is right in the middle, and that and this group has sort of split three ways. That seems quite neat. In which case, that would put it as in Western Asia, somewhere like the Middle East East or the Caucasus or somewhere like that. We can't be confident about that. It could be that it actually is Africa after all, but I think the possibility has definitely been thrown wide open.
What this made me think of is like how we looked at dinosaurs for many years from Europe and from the US. And then in the last, 20 years or so, we've seen this boom of dinosaur fossils, especially feathered ones, from China. And, it started to rewrite the story of dinosaur paleontology. And is the same thing happening here a little bit, in that we've only just got proper sort of human evolution paleontology going on in China, and that's why we're rewriting the story a bit?
I think it's almost more that the story is coming full circle. When people were first investigating human evolution in the late 1800s, the first famous discoveries were all in Asia. So Java man, which is the original Homo erectus fossil, and in the early 20th century, Peking man, which was a fossil sadly lost from China. It was only in the 1920s, when the first Australopithecus fossils were found in Africa, that the idea that humans and our ancestors come from Africa sort of started to be established. And with the advent of genetics in the 1990s, we got this clear evidence of the recent out of Africa migration. And I think that what's sometimes happened is that we've sort of sometimes over-fixated a little bit on the very factual and true evidence that Africa is a huge part of this story, and absolutely indispensable. But I think we sometimes sort of slightly over-focused on that and kind of downplayed what's happening in Asia and elsewhere, which I think is going to turn out actually also to be really important.
It's interesting because for quite a long time the story, it wasn't just Africa, it was East Africa. And in part thanks to DNA evidence, we now know that actually humans were evolving all over Africa, and there was a lot of mixing and diversity. And it's almost like this is part of that broader picture too, that before humans came back to Africa, there were different types of hominins and human ancestors all over Eurasia, I guess.
Yeah, I think so. I mean, one of the things that Chris Stringer said to me was that we've only got fossils really from about like 10% of Africa, something like that. It's mostly from East Africa and South Africa, and from certain time periods in Africa. We've got a pretty good fossil record for like fairly recent members of our species, like the last 100,000 years ago. But the origin points, the older bits, are actually really under-documented. There's two sets of fossils from about 200,000 years ago in East Africa, and then the 300,000-year-old stuff from Morocco. That's very little for 100,000 years worth of evolution and mixing. That's really only 3 data points.
And potentially even longer, because you said if we're as old as 1.3 million years, there's almost 1 million years of missing fossils, aren't there? Where are they? Why can't we find them?
It's a very good question. I mean, one thing to sort of bear in mind is that it's not obvious when in that time period the hominins started to actually be like Homo sapiens, in the sense of actually looking like us and acting like us. When the sort of these 3 groups split from each other, presumably those 3 initial populations were pretty similar to each other, and it's only later that the sapiens-like traits evolved. There's a huge chunk of Africa that's sort of very, very underexplored, particularly the center and the west. There's not actually very many fossils of the right time period from Western Asia. There's loads of like fossil sites in Israel and places like that, but they're generally from the last couple of 100,000 years. There's not very much from 1 million years ago at all. And there's only one hominin fossil from the whole of India, which is a massive area. And there's this one skull called the Nomada skull. Without even sort of speculating as to what happened in that region, something happened in that region, and we don't have anything to tell us about what it is apart from this one skull.
You mentioned Peking man. I should have remembered that, because I've got a model of it in soap on my mantelpiece, which I'm never going to use.
No,
it's
of
there.
course.
It's next to a model of Homo habilis. So I should remember that. But Mike, what is the next, at least for Stringer in this group, what are they going to plan to do next?
So one of the things that they would like to do is to try to bring together the genetic evidence and the morphological fossil evidence, because they on the face of things they do seem to contradict each other. But what would happen if you actually sort of put them together in some sort of massive analysis? What would that tell you? Obviously, they're keen for us to find more fossils from the different time periods and locations that we talked about. Sometimes when I write about a story about human evolution, it sort of feels like it's sort of tied everything together, and it sort of creates a really clean narrative that I can then sort of hang my hat on for ages. This feels more like kicking open a door and discovering that there's this whole labyrinth of other corridors that we didn't know that we were going to have to go walking down.
Love it.
And that, it feels like there's a whole bunch of new stuff that people will now have to go and look for on the basis of this.
There's a whole labyrinth to explore here, Penny.
And we will explore it on this show.
We will. So do hit subscribe. Thanks for watching The World, the Universe and Us. I'm Dr. Rowan Hooper.
And I'm Dr. Penny Sarchet. See you next time.